take 3 routers to simulate this OSPF. Okay, then we have to take 3 switches also to demonstrate we have 3 very different branch office or LAN, and then we're gonna connect all the switches and the router. Guys, if anyone is having any question in between also, you guys can have time to ask me. Yes, so I take few PCs, one PC I will take for this lab purpose. So let's suppose I have this 3 PC. Okay, so just for our understanding, this will be our 1.0 network. Okay, this will be our 2.0 network. This will be our 3.0 network. And as we know, the each and every port of a router should, display or demonstrate the very different network. So still we have this line and this particular line and this line need to be have very different networks. So what we'll do, we'll have this one, let's go 4.0. This one will have the 5.0 and this one will have a 6.0 network. Okay. So now let's configure all the ports. Okay. So let's go for this router. Okay, we'll go for the global configuration mode. And here on this router, GI 0 by 1 will be our 4.0 and 0 by 0 will be our 1.0. So interface GI 0 by 0, IP address will be 192.168.1.1. Okay, and then 255.255.255.0 no sat, and then interface GI 0 by 1, then the IP address will be 4.1 and no sat. And here on this router, let me see it's okay. GI 0 by 0 will be our the interface GI 0 by 0. It will be our 4.2, so IP address 192.168.4.2, 255.255.255.0. Okay, and then no such. Then the next interface is GI 0 by 1. That will be our 5 dot series. So let's give them IP 5.1, 5.1, and then no sat, and then we have interface GI 0 by 2, and then we're gonna give this IP from 6.0 range. So it will be a 6.1 and then no sat. Okay, let's go for this router here again. We'll go for the global configuration mode. Here GI 0 by 0, IP address will be 192.168.5.2. Okay, sorry. 255.255.255.0 and set. And then we have another interface that is R0 by 1. It will be our 2 dot seasoning. So IP address will be 2.1 no set. Okay, now only this router left with the IP configuration part. Copy, and here interface GI0 by 0. This will be IP address 192.168.6.2.255.255.255.0. No set. Then we have interface GI0 by 1, and that will be our 3 dot network. So 3.1. Okay, and then no set. So finally we give the IP address to all the interface of the router. Let's configure our desktop also. So this 1.c is desktop 192.168.1.10, and the default gateway is 192.168.1.1. Okay, and here 192.168.2.10, 192.168.2.1, and this one will be our 192.168.3.10, 192.168.3.1. So we have given the IP address to our PC also. So if you can check here, won't be able to reach to this PC. Okay, first packet is filled just because of the ARP, but even the second packet, it will have a failed message. The reason behind that one is till now we have not configured routing, any sorts of routing, be it a static or dynamic. So now again the very important part here is which let's suppose if we wanna configure this one in as a, let's suppose, area 0, because as you know we have to definitely make one particular area a network as an area 0 because that is our backbone. So for example, what we're gonna say, let me draw something for you guys. So this will be our, okay, this will be our area 0, and this will be our, no, no, this will be our area 1, and this particular will be our area 2. So let me write something. This is area 0, area 1, and then area 2. Okay, now the question is whether we have to manually configure this area border router, or you can imagine which one will be the area border router here. Of course, this area will be our area 0. So all the backbone or in a ISP connection will be with this router in this topology. Okay. So which will be the area border router? So according to this topology, this particular router is responsible to connect with this area. Okay, area 0. Even this particular guy, this particular area guys gonna have a connection with this ABR, and the ABR is the responsible to reach to the area 0 these things. Okay, So let us configure now the routing part. Okay. So for routing part, you have to now understand there is something called process. Okay. So the best part about this OSPF is you can have multiple OSPF process running on the same router at the same time. Okay. So what does it mean? That we have to define a process ID for each process. Okay. So for an example, we're gonna say router OSPF 1. So this is our process. Okay. So this process finished. Okay. Now we have to give them a something called a router ID. Why it is important? It's an identification within the OSPF network. It will give the uniqueness to the each and every router. Okay. So let's suppose if the route, if somehow there, because there are calculation also, even if you will not configure the router ID, there are certain mechanism automatically it will take a router ID. Okay, so there are chances that if it is taking automatically, and if that the calculation is depend upon the kind of ports they are having. Mostly in industry we are making a loop back also. So loop back adapter we are making it, and loop back adapter never going in a shutdown mode. So even though if someone has created two loop back, so there will be always a confusion. Okay, and this router ID is again 32-bit address. Okay, so normally we gonna put it, let's say, starting with 1.1.1, another router 2.2.2, similar to that one. Okay, just an overview of this particular router, that it will have a uniqueness over this OSPF network. So we're gonna say router ID 1.1.1.1. Okay, then now the network part. Okay, so network you have to decide now. Network, which network? This particular we are configuring the router 0. So we are saying this is area 0. So the 1.0 and the 4.0 will be all area 0. Okay. So 192.168.1.0, and there is something called wild mask. Okay. Subnet mask you understand. Okay. Exactly opposite of subnet mask is your wild mask. So let's suppose 0.0.0.255. So I'm saying whatever the first three octet, we don't care. We're gonna only match the third octet value. Okay, and then we have to define the area. So area is R0. This one. Okay. Again, another network is directly connected here. That is our 4.0, and this one is also area 0. Okay. Now come to this router. Okay, and the same router OSPF process will be same. Okay, but the router ID will be very different now. 2.2.2.2. Okay, now we have to define the network. So now check, for this particular router we have three network we have to mention here. Okay, one is 5.0, one is another one is 6.0, and the last one is 4.0. But for each and every, now for this router, each and every network is gonna be belong to very different area. So we, if you are doing any sorts of mistakes here, then your network will have problem. Okay, so network 192.168.4.0, but as we know, according to our topology, this 4.0 is in area 0. So 0.0.0.255, that is our wild mass, and the area 0. Okay, and then the another network is a 5.0. Okay, and this 5.0 is our area 1. So you have to write area 1. Okay, and then see now the they are finding out the neighbor now. Okay, the neighbor will be 1.1.1. This one. Okay, so another one is having 6.0 network, and the 6.0 network gonna be area 2. Okay, so that's it, guys. That's the configuration on this particular router. Let's go for this router. Router OSPF 1. Router ID will be 3.3.3.3, and then the network part will be 192.168.2.0 network. This is this side, okay. So all are area 1. So for this router, both 5.0 and 2.0 is area 1, okay. 0.0.0.255 area 1, okay, and then the 5.0 is also area 1. That's it from this router. Let's go for this router. Here we have 3.0 and 6.0. So router OSPF 1, router ID is 4.4.4.4, and then network will be 192.168.3.0, 0.0.0.0, and the area is 2, okay. And then we have 6.0, this is also area 2, and I think we have configured all the OSPF route. So now let's check. There is some command show IP OSPF. Check here. So you can see here we have it is in area 2. Okay. If you can see here, show IP OSPF neighbor. Okay. It doesn't understand till now about their neighbor. Check here. So IP OSPF. This one is understanding 2.2.2. Okay. So router 0 is this is our neighbor. Okay. That's true. For this one, it should understand the two neighbors. So two neighbors should be so IP was here neighbor. Yeah, it got 3.3 and 1.1. But this one is still not. But why? What we did mistake. Router OSPF1 router is on 92.168.3.0. That's true. This is 66.0. That is also true. Okay. So IP OSPF database. So database is they are having. I was telling you about, right? They this OSPF is maintaining three kind of table. Okay. One is the neighbor table. It doesn't populate till now the neighbor. So definitely we can't communicate from here to here. Okay, there are some thing going wrong on this one anyway. And here, if you can see here, same command. So IP OSPF database. Here you can see this is having the complete database regarding the topology, complete topology network they are having. So if you can initiate the ping from here to here, see they are able to ping. But let us check this particular, they are able to do it or not. No. 3.1 is here, is correct. So GI 0 by 1. Let me troubleshoot this guy. 3.1 is still it is correct. And then GI 0 by 0. GI 0 by uh, 0 by 0 is 6.2, and then 0 by 2. 0 by 2 is 6.1. This middle router is not able to reach to even etc. That's not a protocol for, there is something else. The problem with this packet tracer right now. Yeah. 6 second, 6.2. Come on. This 6.2 is so. Okay. So I will what I do. No router OSPF 1. So I just remove everything from here. So that is what you guys have to troubleshoot, my friend. Okay. But according to our configuration part, I didn't think we did any mistakes. But let's cross verify once again. Router OSPF 1. Router ID is, this is 1, this is 2, this is 3, this is 4. Let's run it is 4.4.4.4. Okay. Then the network part is 192.168.3.0, 0.0.0.255, and area will be R2. And then we have 6.0. No, this is, anyway guys, I think there is something wrong. No, this time it came back. Okay, same thing we did last time. Anyway, that's the strange thing with this, sometimes with the packet tracer simulation, guys. Okay, last time also we did see, now it detects the neighbor. Previously it was not able to detect it. So now if you can see that, so IP OSPF neighbor, see now it can detect 2.2.2. So it will have the database also. So IP OSPF database. See now it has having the database. say now we are able to ping. So that is this is how you have to configure the OSPF with the multiple area. You just need to find out which will be our area border router, okay? And basically you don't have to do anything, okay? But from examination point of view as well as from the interview point of view, they're gonna definitely ask the question. So what is the cheat code or cheat sheet for that one is you have to find out, let's suppose this belong to very different network, okay, very different area. This one is very different area. The router port which is having the same IP address, let's suppose this one, 4.0, with the area 0, 4.0, and here also is like this also belong to the 4.0. It's the 4.1 and 4. So definitely this will be the our area border router, okay. But imagine if we are saying this one is 4.1 and this one is, then maybe this will be in another scenario we could have said that the another router may take the place of ABR, but in this scenario this is your ABR. Yeah, so that's it guys, that's it from my side. If you guys have any question query, you can go ahead.